Stephen Lay, author of Analysis with an Introduction to Proof, has created a comprehensive set of PowerPoint presentations to accompany the 5th edition of his text, and he is making them available to faculty who adopt the text. In this short video, Stephen reviews the benefits of these PowerPoints and provides some examples.
I have found the slides useful in several ways. They are easier for students to read than my handwriting on the board. They help organize my lecture, and I don't skip important points. They enable me to cover more material in a shorter time. I post the PowerPoints online, and they are available for students to review if they have questions or miss a class. Some students print them ahead of class and write notes on them. Most importantly, the PowerPoints enable me to do things that would be very difficult or time-consuming otherwise. Let me give you some examples. Early in the book, we negate the quantified statement. For all epsilon greater than 0, there exists a capital N such that for all little n, if little n is greater than or equal to capital N, then for all x and s, the absolute value of f sub n of x minus f of x is less than epsilon. This is a very complicated statement, but using PowerPoint, I can show how to work through the negation one step at a time. The negation of for all epsilon greater than 0, something happens, is there exists an epsilon greater than 0 such that the something does not happen. The negation of there exists a capital N such that something happens is for all capital N that something does not happen. We continue in this manner. Notice how I use purple highlighting to show the part that is being negated. The blue underlining shows what I've completed, and the red underlining shows what is left to negate. Here is a function that would be very hard to graph by hand. We see that f of 1/2 is equal to 1/2. F of 1/3 is equal to f of 2/3 is equal to 1/3. F of 1/4 is equal to f of 3/4 is equal to 1/4. We continue for fifths, sixths, sevenths, and so on. On the other hand, f of every irrational number is 0. I go on to show that f is continuous at each irrational number and discontinuous at each rational. Using PowerPoint, it is easy to illustrate the proof of the theorem that says the continuous image of a compact set is compact. Here is D, and here is f of D. Let script G be an open cover of f of D. Since f is continuous, the pre-image of each set in script G is open. These pre-images form an open cover of D. Since D is compact, there is a finite subcollection that covers D. The corresponding sets in the range form a finite subcovering of f of D. Hence, f of D is compact. One of my favorite slides starts by graphing the function f of x equals sine x. Then it graphs a few of the Taylor polynomials for f at x equals 0. As the degree of the polynomial increases, the graph of p sub n closely approximates f for values of x that are farther and farther from 0. In Chapter 7, I return to the modified Dirichlet function and show that it is integrable on the interval from 0 to 1. Once again, having the PowerPoint graph is very helpful. Given epsilon greater than 0, there are only finitely many points on the graph that are above epsilon over 2. Make delta x sub I so small that the area in the upper sum of f and p from those subintervals totals less than epsilon over 2. The area in the upper sum of f and p from the other subintervals will also total less than epsilon over 2. Thus, the upper sum is less than epsilon. Clearly, the lower sum is equal to 0, so their difference is less than epsilon, and f is integrable. As I mentioned at the beginning, I have developed PowerPoint presentations for each section in the book. They are available in an editable format, so you can make additions or deletions as desired. I hope you find them as helpful in your classes as I have in mine.